Let's identify some special syntax which are supposed to be used with this particular for loop. Probably when it comes to the programming language, we will not use them deliberately. But in some cases where the examples are based on finding the output of the code, probably in your exams you will find these special cases. Let's identify these special cases. Now, the very first case, generally it is said that a for loop should be associated with 3 expressions. Can I have a for loop with only 2 expressions? Syntactically, no. But through some additional modification, yes, I can use a for loop with only 2 expressions. As we know, just now in the previous video, I have said that I equals to 1, that is E1 is used only once. And however, it is going to be done only once. If it is done only once, then why don't we associate I equals to 1 outside this particular for loop and make this particular for loop to work with only 2 expressions, that is E2 and E3. So here E2 is I less than equal to 10 and E3 is I plus plus. If I write this particular for loop with some instructions within this particular body and ask the system, ask the compiler to evaluate, this will result into an error saying that for loop is missed out with 1 expression. A for loop is associated with only 2 expressions. So in this case, probably for me this might be a condition, but for the compiler this is the expression E1. And this is going to be identified as E3, even though if you have written I plus plus. So automatically it says that the third expression is missing. Somehow I had to make the system or the compiler to understand that E1 has been done at some place. In that case, what I need to do is I need to start this particular for loop, the expression E2, with a semicolon itself. When a for identifies a semicolon directly, it says that E1 has been done at some place. It presumes that this expression E1 has been completed. Now let's go ahead and execute E2. So if E2 is true, again it says execute the loop and then go back and execute E3 and then E2. So for loop says that it can work with only 2 expressions provided that there is a syntactical semicolon which appears before E2. Then only it presumes that E1 has been done at some place. Now, the second way of writing this particular for loop. However, it is said that E3 is going to be done every time when the loop works for the second time. So why don't we write this particular E3 as a part of loop missing out the third expression. So I'll say I equals to 1, let me say I less than equals to 10, and let me identify E3 at this place, and here some statements, and I plus plus at this place. Now if your expression E3 goes missing, here the expression E3 is within a for loop. So here I equals to 1 is E1, I less than equal to 10 is E2. So it says if true, execute the loop. It will execute all the statements. I plus plus will make the loop to execute for the E3 statement, and then when it goes back, it finds directly a semicolon. If it doesn't find a semicolon, then it will be a syntax error, because a for loop requires 3 expressions. So if a for loop requires 3 expressions, a semicolon makes the system to understand that E3 has been already completed. So let's go ahead and check the condition at this place. This is one syntactical variation of the for loop, where a for loop can miss with E1, can miss with E3. Can I have a for loop with all the 3 cases, all the 2 expressions missing, E1 as well as E3? Yes, I can have a for loop with that particular syntax also. Let me quote that as the third case with this particular for loop. I'll say for, I'll have I equals to 1 outside this particular loop, and here I'll say I less than equal to 10, only E2, and then your statements will be there as it is, and here I'll say I plus plus. So here you will find that expression E1 has been done before for loop. Your expression E3 is done within the for loop. I have only a condition associated with this particular for loop. But a for loop syntax requires 3 expressions. If you say 3 expressions, I can convince the system, I can convince the compiler by placing a semicolon before this particular condition, making this particular I less than equal to 10, presume that E1 has been done at some place, since go and check the condition. If the condition is true, execute all the instructions and then execute I plus plus. When you go back, again place a semicolon. not a semicolon after the round brackets. It will have some different meaning. We'll explain this at the later stage. So a semicolon has to be there before and after the condition, which means that this particular for loop is now working similar to while loop. The syntax might say that this is a for loop. The syntax might say, since I've used the keyword for, it might say for loop, but this is not a for loop. This is just one while loop itself. If you compare this example with the previous example which I have shown in the previous video, where your while was used with only a condition. So it means that any while loop program can be converted to a simple for loop program. If I have a while loop program and if I ask you to deliberately convert it to for loop, how do I do that? In that case, what I'll do is I'll replace a while with a keyword for. The condition which is associated with the while will be now having a semicolon before and after that. And then automatically the for loop, the while loop will work similar to a for loop itself. This is the third case which you're supposed to remember this particular for loop. So basically, you can miss out E1, then start with semicolon. If I miss out E3, end with semicolon. If you miss out E1 and E3 both, your E2 should be preceded and succeeded by a semicolon. Question comes, can I have all the expressions missing? Yes, you can have all the expressions missing. Let me put this as the fourth syntax. I'll have a for loop followed by at least 2 semicolons in the brackets. Now, as you know that when a semicolon is identified to the first case, it will work to similar to first case one. So what it assumes is, it assumes that E1 has been done someplace. I have E2 missing. If E2 goes missing, in that case it says, if E2 goes missing, in that case it says that E2 is considered as true. If you miss out any one expression in a for loop, if you miss out a condition in the for loop, it will always presume that it will be considered as a true. Hence execute the statements and then go back and recheck the condition. Now before it checks the condition, again it finds a semicolon. It means that E3 has been done at some place. Go to the condition is not written. If not written, it will be assumed as true. So when the condition goes missing, it will be assumed as always true itself. Since a for loop can miss out E1, can miss out E3 and can miss out E2. If E2 is not written, it will assume a for loop with this particular semicolon itself. These are the 4 separate examples which you're supposed to remember. We will not use them into our programming language, but definitely we'll have some cases, some find the output examples which are used with this particular part itself. So we'll have one more case, the 5th case of this particular syntax. So let's deal with one more special case where a for loop is used, but will not put it deliberately. Right? Suppose if I have a for loop with this syntax. Now if a for loop goes with this particular loop, for I equals to 1, r is equal to I plus plus printf %di. No prize for guessing this particular output. If you wish, you can still make a guess. What is the output which you guessed? Yes, you guessed it properly, saying that it was I equals to 1, 2, 3, 4. So it will print all the numbers from what to what? 1 to 10. 1 to 10. Now, what if I place a semicolon unknowingly at this particular fine? If I place a semicolon unknowingly at this particular for loop, how the example produces and what will be how the example works and what will be the output which it produces. How to make this? Take a pause, guess it, and then listen to the next statements carefully. Don't always continue the video. Always make a pause whenever example is written. Try to guess what will be the output, and then you can watch it and then you can conclude whether the output which you guessed is proper or not. So if I place a semicolon, it will print 11 on the screen. Output is 11 on the screen. How? Logically, it should have printed all the numbers from 1 to 10, but now it prints only 11. How? Check this. When a for loop ends with semicolon, this is how the loop works. It says, start with this particular I equals to 1, then go to the condition that is I less than equal to 10. Now, if the condition is true and if a semicolon appears, don't go to statements, go to I++ directly. If the condition is true, go to I++ and then recheck the condition. So now the loop gets stuck up into the horizontal path at this place. If a semicolon is not there, then it will take a traditional vertical execution. If a semicolon exists, it will have a horizontal execution. So here, when a semicolon is placed, the loop now takes a horizontal execution rather than a traditional vertical execution. In the absence of semicolon, when the condition was true, it used to say execute the statements. But this time, when there is a semicolon, what it does is, it will now go and execute it horizontally. So it keeps on checking this particular condition again and again, till your condition remains true. So let's work with this particular example. I is 1, 1 less than equal to 10, true, I++, make it I as 2. 2 less than equal to 10, true, again go back. 3 less than equal to 10, again go back. At one point of time, I is say 10. After incrementing I is 10, 10 less than equal to 10, true. True in the sense, go to this particular I++. So I will be now what? 11. So when you go back, 11 less than equal to 10, false. If this is false, now all the instructions which appear after this will be now identified as a statement X, which will be executed only once when the loop ends up. I'll say this as statement X. So here, this curly bracket is never treated as the begin of for loop. This is just a simple curly bracket which says begin of a block. C has got this advantage that you can place these curly brackets at any place of your choice by just placing a curly brackets around the set of instructions. If a for keyword appears, then that will be a for loop block. If not, it will be simple. So here, the curly bracket is not identified as a begin of for, it will be just an ordinary bracket, printf %di. When the for loop was made as false, your I was having a value as 11. So it will print 11. The curly bracket says not the end of for, but the end of a block. And after that, it will continue remaining code. So here, a semicolon makes a for loop not to execute vertically, but to execute horizontally. So you can make a guess of this particular part. So generally, when you practice it at the initial stage, we have a tendency to place always a semicolon. If a for loop ends up semicolon, you will have some different output which is not going to match with our results. So you are supposed to identify, is there a semicolon placed? And a for loop ends up with some infinite operations, check out whether E2 is written or not. These are some of the special cases. We will have one more additional case, sixth case in this particular for loop. The last case of this particular for syntax. Suppose if I have for I equals to say 1, I less than equal to say 5, I++, and after that I'll say again I++, and here I'll say printf %d, I, and here again I'll say I++. Can you make a wild guess of this particular output? Yes, answers please. So you can now say, probably you might have thought the answer as 1, 3, 5. Okay, since it ends up at 5, 1, 3, 5. No, that is not the case. What will be the output of this particular program? How exactly this particular program behaves? Now here, when I ignore curly brackets, how the loop behaves? In the absence of curly bracket, your for loop is going to work. But here, the repetitions are restricted to only the first instruction which appears after this particular for. So here, when a for repeats, so here the repetition goes with only I++ and then it goes back to this particular part. So here, printf and this entire part is now identified as what? Statement X. So it means that a for loop has got a tendency to repeat, but the repetitions are restricted to only the first instruction. So let's work and find the output of this particular code. So I is 1, 1 less than or equal to 5, true. True in the sense, increase the value of I. So I will now become 2. Again go back, I becomes 3. 3 less than or equal to 5, true. I++, make it as 4. Go back, 4 plus plus, that is 5. 5 less than or equal to 5, true. True in the sense, I++, make it as 6. Go back, I++, make it as 7. 7 less than or equal to 5, true. True in the sense, print 7. So the output in this case is 7. And I++ will make it as 8 at this place. A for loop will identify the instructions by a pair of curly brackets, not by the alignment of the instruction. Don't believe that your printf was exactly written above this particular I++, hence your printf becomes a part of for loop? No. When curly brackets are there, it will place a set of instructions. If curly brackets are not there, in that case, it will place only one instruction as a part of its block, and the rest all instructions will be identified as I++. Clear that? So in this entire video, we found what are the various special cases with this particular for loop. What if E1 goes missing? What if E3 goes missing? What if E2 goes missing? What if all the three expressions are going to be missing? And then the impact of semicolon if it is done at the end of for loop, and the impact of these curly brackets when they are not associated with this particular for loop. Thank you.